This is ME 416 Project 4 Finite Element Analysis of Heat Transfer in Fins. I'm Cody Little.
And I'm Jason Seeley.
We were to predict the temperature along the fin and the rate of heat transfer through the fin using ANSYS Workbench. We had to design two different fins that are infinite in length and made out of copper and aluminum. We also had to meet the design constraints seen in the figure below. We designed a 1 cm by 1 cm rectangular fin and a 1 cm diameter pin fin. We also decided to use a fine mesh to produce more accurate results. For the aluminum rectangular fin, we found the heat flux was 246,750 watts per meter squared, which was then multiplied by the cross-sectional area, which gives us a heat transfer rate of 24.675 watts. When comparing this to the theoretical result, we found that there was only a 0.036% error. The discovered heat flux for a copper rectangular fin multiplied by the cross-sectional area of the fin yielded a heat transfer rate of 34.42 watts. When comparing this to the theoretical value, we found that there was only a 0.073% error. The experimental rate of heat transfer for our aluminum pin fin was found to be 19.77 watts, and the theoretical heat transfer rate was found to be 19.37 watts, which was only a 2.08% error.
The experimental rate of heat transfer for a copper pin fin was found to be 27.42 watts. The theoretical rate of heat transfer was 26.83 watts, resulting in a 2.21% error. To calculate the temperature along a fin, we used the equation seen here for infinite fin and used Excel also. For an aluminum rectangular fin using ANSYS, it was found that the fin reached 20 degrees in about 45 centimeters. This is also very similar to the theoretical data seen in the Excel graph here. Our copper rectangular fin reached 20 degrees in about 50 centimeters. Theoretical data suggests that the fin will reach about 20 degrees in 58 centimeters. Comparing the ANSYS results and our theoretical for the aluminum pin fin yielded similar results where the temperature of the fin reached 20 degrees in about 40 centimeters. A copper pin fin reaches 20 degrees in about 55 centimeters according to our ANSYS data. This is very similar to the theoretical data seen in the graph here. In summary, the experimental data was very similar to a theoretical. Also, we would suggest that a copper rectangular fin is used due to the high thermal conductivity and the large surface area.